Greetings, AI students. This is an illustration of something called a feed-forward neural network. It's the type of neural network we'll be using in this week 3 illustration and labs. And it has, it was the thing which made neural networks work. It's the architecture which caused neural networks to be actually go into industrial production. And what have we actually got? This input layer represents, each of these green dots represents one input coming in. So here is showing 4. In fact, you will have 28 squared pixels, 784 numbers, where each number represents 1 pixel's grayscale value. And then we'll have what's called the hidden layer. And the hidden layer is that neuron that we saw in last week's lab. And here is an example of what we're talking about. So one hidden layer neuron that's shown here in the middle, it is getting input from 784 inputs. And each hidden neuron gets 784 inputs. Each neuron can see all pixels, and there's a bunch of weights. So all of these are the weights that you were training. Okay, you had 2 inputs and 2 weights, so you could do it by hand. But here we have this many, weights, 784 weights, and then there's the bias. So there's also a bias number coming into the neuron. This all gets summed up. So the weight for the ith input times the ith input's value. These input values are no longer 0 and 1. They're going to be, real value numbers. The grayness of the brightness of a pixel times the weight, and then the bias number coming in is also going to be another adjustable thing. So the weights are adjustable, the bias number is adjustable. It goes through a function, and we get to the output. And this function will be ReLU, which we've seen, and it's just a line in the positive quadrant, and if this whole sum turns out to be negative, then 0 comes out. That's all. So now go back to this guy, and each of these neurons in the middle is like the neuron that you trained with 784 inputs. How many are we going to have? Well, there's no good way to know how many of these, quote, hidden neurons to make. We're going to put 128, it's just kind of an arbitrary number, into our labs, and it'll work pretty well on the digits. And so, but that's how many there will be. So how many weights do we have? Well, each hidden neuron looking backwards has 120 or 784 different inputs, right? So there's 784 weights coming in plus 1 bias coming in. So 785 numbers for each of 128 hidden neurons. Multiply that out, you get a big number, right? It's over 100,000. Okay, the output layer, what our task was, you recall, it's going to be a classifier. We need to essentially output a decision. Is this number 0 or number 1 or number 2, like that. The way you typically will do that is you'll have 1 neuron for each decision. Imagine the output layer neurons as little LEDs. And we want the correct LED to light up and the others to stay dark. So we will have 10 output neurons. The output neurons, what? Well, it's the same story. Each output neuron looks just like this. It's got what? 128 inputs from the middle layers, plus a bias, goes through some function, and then the output comes out. Okay, so we'll have a whole bunch of output neurons, a whole bunch more weights going in there, right? Each output neuron should it's never going to be exactly 0 or 1. But we'll have to come up with an error function which sees how close we are to one neuron lighting up and the others staying dark, one of the output ones. So, I mean, if one of them is at 0.5 and another one is at 0.2 and a bunch of the others that are about 0.1 or so, okay, that'll be not great, but much better than they're all equally lit. Okay, so that's the way that's going to work. It's going to have a way of deciding for the error function, which is how close we are to one very high and all the others very low. And then to make the final decision, we're just going to pick the brightest one. So the final category is going to be which is the output neuron that is producing the most output. So number 0 or number 1, like that. So that is the way we can use, put those neurons together. Each of these neurons is a lot like the ones which you trained by hand last week. So 128 in the so-called hidden layer, and then 10 in the output layer. All right? And the difference is, instead of just one, we have all connected together into 2 layers in this thing called a feed-forward network. So we can't do generative AI with this. There are a lot of things we can't do. We can't look at long sequences of data with this. So there are limitations. But on the other hand, this really was really successful at a whole bunch of tasks, of which classification tasks are very useful. So that's the model of neural network. That'll give you an idea of how many trainable parameters are inside and how it works. And in the next video, we'll get to see some more.